So let's start with a circle. What is the definition of a circle?
It's the set of points in the second dimension that are the same distance away from a specific point.
Okay.
Like that point.
Like the center of the circle.
Yeah, so this is what a circle looks like if we draw it on a plane.
Yeah.
What would the same definition say if we restricted ourselves to a line?
So
What would a circle, what does a one-dimension, 1D
Well, it's
version
a-
of a
it's
circle
a-
look like? I gotta be
Well,
careful
there's a
about what
lot
I'm
of
saying.
points, just like it's basically just a line.
I think it's actually just 2 points.
Okay.
Because the circle in one dimension would be the set of points that are the same distance away from a point.
Okay.
So,
Would be
like,
one
there's-
would be 2 points that are.
would be one there and one there.
Yeah.
So 1D circle.
One there and one there. And how about in zero dimensions?
Just
So it's just the center. It's
Yeah.
just the center of a circle.
Yeah.
that's the point.
Yeah. So, what about a sphere?
Sphere. Well, that would be like the center of a sphere, and you take circles, and they're all the same distance.
How do we define what a three-dimensional?
So
a
it's
sphere in three-dimensional space.
oh, there's a lot of circles that. Oh no, it's a lot of points that are the same distance away from a certain point in the center.
Yeah, it's the same thing. So
Yeah.
the points that are the same distance away from the center.
Yeah.
And what do you think it's going to be in four dimensions?
Well, probably same thing.
Same thing.
Yeah, but
Except you have another dimension.
You have another dimension.
we
And
probably
so-
have more spheres inside it.
Yeah. So let's see how we can think about walking up dimensions here. I'm going to start with how the circle in one dimension on the line relates to the circle in two dimensions. And the way, were you going to say something?
Well, yeah, I can see how it relates,
Oh, okay, awesome.
and also how the circle relates to the sphere. They
Okay.
relate in kind of the same way. So this circle, you can think of it as infinitely many lines. Like if you were to slice it with a plane,
Mm-hmm.
at first if you slice it down here, you'd get nothing.
Okay.
Then as you move the plane up, you'd get a point, and then a small line, and then bigger and bigger lines until you reach the diameter of the circle.
Mm-hmm.
Then it shrinks back down to a point,
Mhm.
and then nothing.
Okay. Now let's talk about, instead of slicing with a plane, just with a line. So what happens? We have a line down here, doesn't hit the circle at all. We have a line here, just touches it just in one point. That's all we see is one point. So you almost like imagine like a circle passing down below. And if the line is up here, all of a sudden we see 2 points.
Yep.
Where have we seen 2 points on the line before?
Right here.
And the one
Yeah.
with
And then we go up,
2
the
points.
diameter.
they're spread out the most, and then they kind of shrink back down again.
Yeah.
So in a way, we can think about projecting this circle down from 2 dimensions down to 1 dimension by saying, what would we get? We would get a point here.
Yep.
We would get this sequence of circles going out until we got the diameter,
And we went back in.
and then we went back in until we're back to here. So we would basically end up filling in the line in between the 2 points on our circle. Now, how many times does every point right here get covered?
Twice.
Okay, what do all the points get covered twice?
Well, no, these two only get covered once.
Yeah, it's interesting. There's 2 points, the end points, that only get hit once.
But
Everything else gets
there's
hit twice.
infinitely many points in between them.
That's right. And every single one of those infinitely many points corresponds to 2 points on our 2-dimensional circle. Except for the endpoints, which only correspond to 1. Okay?
Yeah.
So let's move on and talk about that same idea with the sphere.
Okay.